Hey everyone, I'm Praveen and welcome to AI Sparks, where artificial intelligence meets innovation and excitement. On this channel, we spark curiosity and ignite imagination with AI powered insights, tutorials, and explorations. From machine learning to robotics, we'll dive into the future today. Imagine this: an AI agent is booking your flight. It's unsure about your dates, unsure about prices, unsure about your preferences. But instead of stopping, it keeps going, it commits. And the mistake costs real money. This exact problem is at the heart of the paper towards reducible uncertainty modeling for reliable large language model agents by Changdae Oh and Sharon Lee, along with collaborators across multiple universities. This paper asks a bold question: what if uncertainty doesn't just grow? What if it can shrink? Most uncertainty research treats large language models like calculators. You ask once, they answer once, and we measure confidence in that single answer. But real agents don't work that way. They talk, they ask follow ups, they call tools, they change the world. In agent systems, uncertainty unfolds across time, across actions, across consequences. Yet existing methods assume uncertainty only accumulates more steps, more risk. The authors argue this assumption is fundamentally wrong. Here's the key insight: agents operate in interactive environments, and interaction creates information. When an agent asks a clarifying question or queries a database, uncertainty can decrease. So instead of modeling uncertainty as a one way climb, this paper reframes it as a bidirectional process. Uncertainty can rise or fall depending on the action. That single shift changes everything. To make this precise, the authors define an agent's life as a trajectory. Each step has an action, an observation, and an evolving environment state. Together, these form a stochastic. They define uncertainty at two levels: turn level uncertainty, trajectory level uncertainty. This formulation is powerful enough to include single step QA, chain of thought reasoning, and full interactive agents, all under one framework. Here's the problem with existing approaches: they treat every step as equally risky, but not all actions are the same. Thinking silently is not the same as asking the user. Writing to a database is not the same as reading from it. The paper shows cases where a highly confident agent fails, while a less confident but more interactive agent succeeds. Existing UQ methods completely miss this. This leads to the paper's central idea: agent uncertainty should be gated by interactivity. The authors introduce a conditional uncertainty reduction process. If an action is interactive and evidential, then it can reduce uncertainty. Otherwise, uncertainty propagates forward. Mathematically, they use information theory, mutual information, entropy, and gating functions to make uncertainty directional and interpretable. This is the first framework that allows uncertainty to go down on purpose. This isn't just theory. The paper shows implications for healthcare agents deciding when to ask humans, coding agents choosing whether to commit or explore, robotic agents deciding whether to act or reason. In all cases, uncertainty becomes a control signal, not just a diagnostic number. The authors are honest about the challenges. Long trajectories are hard to evaluate. Black box models hide probabilities. Multiple actions may be valid at once. And if misused, uncertainty signals themselves could be exploited. This makes careful design essential. The paper ends with a powerful metaphor: living systems survive by pulling negative entropy from their environment. And the same must be true for AI agents. Reliable agents don't just think, they interact, and by doing so, they become more certain. If you found this helpful, hit like, subscribe, and comment which AI system you want to build next. Stay sparked. See you in the next video.